Hello everyone. I hope you're okay, and I really hope, guys, that you are preparing for your exam. You are studying hard. There are sleepless nights and stuff. These videos, guys, are there to help you to just to confirm the knowledge you have. Yeah, well, to be at ease. Okay, I got this. I got this. Okay. That question, guys, of the promised question papers. Okay, we are told that the constant ionization values for two acids, which are oxalic acid and carbonic acid, are as follows. Define the term weak acid. A weak acid is an acid that ionizes partially in water or in a solution. It does not ionize completely. We can say is an acid that ionizes partially, or is an acid that ionizes incompletely in water. Which acid, oxalic or carbonic, is stronger? Give a reason for your answer. If you can check the values here, guys, the constant ionization for both acids, the one for oxalic acid is greater than that of the carbonic acid, which simply means that the oxalic acid is a stronger acid compared to a carbonic acid. Alright, together we compare those two based on the constant ionization. Okay, and then we are told that oxalic acid ionizes in water according to the following equation. Okay, we are given the equation for oxalic acid. We are asked to write down the formula of the two bases in the equation. If you guys check the fourth reaction, we have an oxalic acid. The COOH with the 2 outside is the oxalic acid. How do we know that? It ionized in water to give away 2 protons, and then we ended up with COO2. All right, together. So since COO2 is an acid, that means H2O was the base, but it is a base. We can even give a reason for that. Initially it was H2O, and then after it became H3O plus. So the base that we have, the first one is H2O. Are you together? And then whenever we focus on the reverse reaction, we have H3O plus. Are you together? And then later it will become H2O. That means H3O plus have donated a proton, which simply means H3O plus is the acid. Are you together? And then we have COO2, and it will later become COOH with the 2 outside. That means COO2 is the base because it accepted 2 protons for it to become the oxalic acid. So another base that we have is COO2 with the 2 minus there. Okay, and then we are told that learners prepared 2 cubic decimeters of sodium hydroxide solution of concentration of 0.1 moles per cubic decimeter. Calculate the pH of the solution. I know that whenever my sodium hydroxide dissociates, it will form Na plus and then the OH minus ions, right? Remember that, guys, pH is always given by the H plus, the concentration of the H plus ions. So we can simply, we know that the concentration of our base is 0.1, right? Okay, I know that 1 mole per cubic decimeters of sodium hydroxide will give me 1 mole of the hydroxide ions. but now I don't have 1 mole per cubic decimal. I do not have 1 mole, rather I have 0.1. I want to know how much of the hydroxide ions will I form. Simply cross multiply, then X, which represents the concentration of the OH minus ions, is also 0.1 mole per cubic decimeter. Right, together. So which simply means that I can simply find my POH, which is the negative log of the concentration of the OH ions. Negative log of 0.1. What do I get? Negative log of 0.1. I simply get 1. And then for me to calculate my pH, guys, I'll simply say pH plus POH will give me 14. I want to find pH. I calculated this to be equal to 1, so my pH will be equal to 13. Are you together? I always prefer using the POH route, guys, because it's always neater. But there is another way. There is another way. Let me show you another way right now. Remember that we calculated the concentration of the OH ions to be 0.1, right? We can use the constant ionization of water. H3O plus multiplied by the OH minus is always 10 to the power negative 14. pH is determined by the H3O plus ions. This is 0.1. I have 10 to the power negative 14. Whenever I divide both sides by 0.1, I'll simply have H3O plus is equal to 10 to the power negative 14 divided by 0.1. I'll simply get 10. It's 1 times 10 to the power negative 13. So therefore, for me to find my pH, simply say pH negative log of the hydronium ion, which is negative log of 1 times 10 to the power 13, which is simply 13. So it's up to you guys. You can use either way, but I prefer the POH route because it's more neater. It's more neater. Okay. During a titration of the sodium hydroxide solution in question 7.4 with dilute oxalic acid, the learner finds that 25.1 cubic centimeters of sodium hydroxide ion neutralizes exactly 14.2 of the oxalic acid. The balance equation for the reaction is as follows. They want us to calculate the concentration of the oxalic acid. Since, guys, there's complete neutralization here, we are told that that's both the acid and the base have neutralized. We can simply use our titration equation. CaVa all over CpVb is equal to Na over Nb, right? The concentration of the acid is the one that we want, but I do know that the volume that was used for the acid is simply 14.2 cubic centimeters, and the concentration for the base is 0.1. The volume for the base which was used is just 25.1 cubic centimeters. Na and Nb, guys, they do not represent the number of moles. Please keep that in mind. Na and Nb, they represent the stoichiometric coefficient. Since I took my acid as substance A, the the coefficient of my acid is simply 1 there. Are we together? And the coefficient of my base is simply 2. So all I need to do now is to just calculate the concentration of the acid. I'll obviously do my mathematical gymnastics, and then let me see. I'll simply say 0.1 multiplied by 25.1 all divided by 14.2 multiplied by 2. And then the concentration of my acid is simply 0.087 mole per cubic decimeter. Okay. Following question. The following indicators are available for the titration investigation. Which one of the indicators above is most suitable for the titration? Give a reason for your answer. The one which is most suitable for the titration is indicator C. Why am I saying that? I'm saying that because the pH range for the solution will be, firstly, the base will be in excess, which simply means that the pH will be above 7. Are you together? So since the base is in excess, that means the indicator that you must use, it should indicate the pH of greater than 7. Are you together? So indicator C is the one which is most suitable for this titration reaction. Guys, that's the end of the third video. Please stay tuned. Video number 4 is coming.